Hi everyone. Let's complete the reactive example with the reactive web client. First, I will add a reactive Elastic Query web client module and then add the dependencies. I will use Elastic Query web client common module to get common dependencies that are also used in the non-reactive web client. Then I will change web dependency to WebFlux while also removing some dependencies like load balancer for simplicity. So here I need Elastic Query Web Client common, app-config data, Spring Boot Starter time leaf, Spring Boot Starter WebFlux, Spring Cloud Starter config, Spring Boot Starter security, Lombok, and Spring Boot Starter validation, and finally the Spring Boot Starter test. I will also add the Spring Boot Maven plugin with build image coil here, in case we want to create a Docker image for this client. Now let's add com microservices demo reactive Elastic Query web client package and create Spring Boot application class reactive Elastic Query web client application. Then I will add application YAML configuration file and add the config server repository file for this service, which is called config client reactive Elastic Query web YAML. I will put Spring WebFlux base path and set timeleaf reactive max chunk size and then the Spring codec max size as extra parameters for this reactive version in the configuration. Please do not forget to commit and push config changes as usual. Let's also add Bootstrap YAML file here for config server properties. Then I will add logback.xml file for logging. This is the similar file that we have used in other microservices. Finally, I will add simplified timeleaf templates that doesn't have the authentication logic. These are the same templates. I only removed the authentication related tags, as we won't apply authentication in this reactive version. I will also add reactive Elastic Query web client application test class to create a simple context load test here. Then I will first add a config package and add a simple security config class for WebFlux security. Again, I will not apply any security here for this example for simplicity. Then let's also add a web client configuration and set the default values. It has the same values as was in the non-reactive web client. Then let's create Elastic Query Web Client interface under service package, which will return a Flux object. Then implement it with the Twitter Elastic Query Web Client class. I will annotate this class with service annotation to make it a Spring managed bean. And create a log variable as usual here. Then I will inject WebClient and Elastic Query WebClient config data objects. I will use qualifier in the constructor injection of the WebClient here, as in the non-reactive WebClient. Then I will create getWebClient method. And in this method I will call getWebClient method to convert the response to Flux using the body-to-Flux method. As you see, I don't call the block method here, because this is not a blocking operation anymore. Alright, then finally, I will implement the controller class. I will create query controller and annotate with controller annotation. First, I will create a log variable and then inject Elastic Query WebClient. Then create index, home, and error page methods with getMapping. Those are the same methods as in the standard web client. Then I will create query by text methods with post mapping with path query by text. For request model, let's use valid annotation here to validate the object. Then inside the methods, I will call getDataByText methods from the Elastic Query Web Client. Then I will call the log methods on response model so that it will observe reactive stream signals and we can trace them using logger support. To reactively get response into TimeLeaf, here I will use iReactive data driver context variable and wrap the Flux response into this reactive class. Then I will send it to TimeLeaf template. Also, I'll add default search text and empty request object to the TimeLeaf. Then I will log and return to home template. Note that here I use a second parameter for the reactive data driver context variable class and set it to 1, which will set the buffer size as 1 so that I will see the results one by one on the web browser. After that, please run first local Elastic cluster and then the config server. Then I can run reactive service and the reactive web client. Now I should be able to get chunked results in each 500 milliseconds on the TimeLeaf page. Let's try this on the browser. As you see, I get responses in chunks from Reactive Query Service, which uses Reactive Elastic repository, and here I use the Reactive TimeLeaf component. Alright, great job so far everyone. We finished the basic reactive example. Now I will return to where we left and continue by adding OAuth2 and OpenID Connect protocols to the standard web client and query service in the next lecture. So I will see you in the next lecture.